Hi, my name is Stefano Mezzini and I'm a biology PhD candidate from the Quantitative Ecology Lab at UBC Okanagan. I'd like to start today with a little bit of history, specifically about the land before Edmonton, known in Cree as Amiskwacy, meaning Beaver Hills. This area was historically inhabited and is still inhabited by the Nehewak, Stoney Nakoda, Niitsitapi, Tsuut'ina, and Michif peoples. During the late 1700s, this area was coveted for fur trading, and because of that the Hudson's Bay Company built Fort Edmonton, which was known in Cree as Amiskwacy Waskaigan, or Beaver Hills House. Over the years, Fort Edmonton was rebuilt and moved multiple times. This picture here shows Fort Edmonton in 1870 just over the North Saskatchewan River. By the early 1900s, Edmonton was incorporated into a city and in 1905 officially became Alberta's capital. In this picture you can see Jasper Avenue, just outside the Edmonton Conference Centre, in about 1910. And within the span of about 100 years, Edmonton has grown substantially and transformed into something that we are more familiar with today. But Edmonton, of course, is not the only thing that has changed in North America within the last 100 years. Using temperature data from 1910 to 2000 as a reference average, we can see that the climate has warmed substantially, particularly within the last 40 years. This is significant for mammals, as heat affects both their behavior and their fitness. Mammals, in fact, are sensitive to hypothermia, or overheating, especially large-bodied ones, and excessive heat can limit their movement rates and even cause physiological damage. When temperatures are high, mammals will often reduce their movement rates and search for thermal refugia, areas that are buffered from extreme temperatures. However, mammals' movement behavior also depends on a series of other drivers, such as time of day and day of year, the availability of resources, the presence of predators, and the presence of conspecifics. Temperature, in turn, affects each of these drivers as well, so it's important to disentangle each of these interactions carefully when estimating the effects of temperature on movement behavior. So given how much landscapes have changed within the last 100 years, one of the questions I wanted to answer with my research was, how and where will mammals move in 2100? I focused on Western Canada in part due to its variety of habitats and wide range of elevation. Our dataset included 1.5 million GPS locations across 6 different mammal species and 2 different caribou ecotypes. Specifically, we had data from boreal caribou and wolves, southern mountain caribou, grizzly bears, elk, cougars, and mountain goats from Cathedral Park. For now, let's just start simple using the data on the boreal caribou. And let's start with how temperature affects how caribou move. These two figures show how boreal caribou altered their movement phenology in response to temperature. Red areas indicate less movement, while green areas indicate more movement. Panel A shows relative change over time of day in early October, while Panel B shows changes throughout the year. In Panel A, we can see that caribou moved the least when temperatures were between 0 and 20 degrees, and they moved about 4 times as much when temperatures were below minus 20 degrees or above plus 20 degrees. Seasonally, caribou moved the least on cold winter and spring days, as well as on hot summer days. They moved the most in fall and on warm winter or spring days. I then used these estimates to project how boreal caribou will move under different climate change scenarios, but there was no appreciable difference across any of the scenarios. The projected changes under the best case scenario in blue are indistinguishable from those under the worst case scenario in red. However, the projections did not account for daily cycles, and the seasonal trends likely cancelled out since heat caused caribou to move less in summer and more during other seasons. So that's how temperature affected how boreal caribou moved, but how did it affect where they moved, meaning their habitat selection? To answer this, I used a simple resource selection function that accounted for percent tree cover, elevation, and distance from water. I used such a simple model specifically because I wanted the results to be comparable across species. In this figure, we can see how temperature affected boreal caribou's habitat selection, with purple indicating avoidance and green indicating attraction. As temperatures warmed, caribou shifted to less forested areas and were more likely to move up elevationally or away from water. If we apply these models to the caribou's current range, we can see that their habitat selection is stronger near 0 degrees in the middle panel and is weaker at plus or minus 15 degrees, suggesting that their selection strength weakens at extreme temperatures. But again, projections of future selection strength did not show much change over the decades, and there are no substantial differences across scenarios. This is likely in part due to the weaker selection at extreme temperatures, since yearly averages do not show the seasonal variation in habitat selection. Still, something interesting happens if we focus specifically on the predictions for 2100. Under worst scenarios, we see not only a decrease in average selection strength, but also a widening in the distribution. This suggests that caribou may be forced to traverse patches they would generally avoid as they travel to high selection patches, or that they may face stronger seasonal fluctuations in habitat selection. So far, we've looked at how resources, phenology, and temperature all impact boreal caribou's movement behavior. However, their movement also depends on that of their predators, which, in turn, also depends on temperature. While I did not look at predator-prey interaction specifically, we can look at how temperature affected boreal wolves' movement behavior to start formulating some hypotheses. Overall, wolves adapted their movement rates to temperature similarly to caribou. Generally, they moved the least between 0 and 20 degrees, and more above 20 degrees, except for in summer, when hot temperatures actually caused them to move less. As with caribou, habitat selection for wolves' main range was highest near 0 degrees and lower at colder or hotter temperatures. However, unlike caribou, wolves showed a strong selection for water, particularly at or below 0 degrees. We can see this most clearly in the middle panel, where the entire river system is a dark green. If we compare the two figures side by side, we can clearly see that both species occur in similar ranges, but that caribou tend to avoid the river system where wolves are often found. Thus, wolves spend more time in areas caribou tend to avoid, but they also often move across caribou habitat. Since both broaden their habitat selection at extreme temperatures, we may expect encounter rates to decrease during hot summers. However, warmer winters would likely result in an increase in encounter rates as temperatures move towards 0 degrees and both species increase their selection strength. And while I also have results for each of the other species, I unfortunately don't have the time to cover each of them individually, since there were no common trends across all groups. So here are two honorable mentions. Number 1, cougars' sensitivity to temperature varied smoothly with the seasons, such that relatively hotter temperatures reduce their movement rates regardless of the season. And number 2, grizzly bears showed lower movement rates shortly before or after hibernation and moved the most in summer, but warmer temperatures resulted in less movement in the fall. With respect to resource selection strength, there were again no common trends across all species. At warmer temperatures, some moved towards tree cover while others moved away from it, some shifted up elevationally while others moved downwards, some avoided water while others were drawn to it. However, these estimates should all be interpreted carefully since all three variables are somewhat correlated. And while there is substantial variation across species responses, we do see some common trends in our climate change projections. Bold lines indicate the projected median change in distance traveled throughout the years, while the transparent ribbons show the range between the top 5% and bottom 5% change within each species range. On average, boreal caribou and grizzly bears are predicted to move approximately the same distance throughout the years, while southern mountain caribou and mountain goats are expected to travel longer distances, and cougars, elk, and wolves are expected to move less. Overall, worse climate change scenarios always resulted in more severe changes. We also found common trends in our projections for habitat selection strength. Boreal caribou, grizzly bears, and wolves are not projected to alter their selection strength substantially, while southern mountain caribou and mountain goats are expected to show widespread decreases. Cougars and elk are projected to show decreases in median selection strength, along with stronger selection for some parts of their habitat. Again, if we focus only on this change in selection strength by 2100, we can see that for all species, worse scenarios are expected to result in wider ranges of selection for and against habitats, although the trend is most visible for southern mountain caribou, cougars, elk, and mountain goats. As the climate warms, these species will likely shift their range or be forced to live in a habitat they would prefer to avoid. Effective conservation will therefore require careful proactive action. Predicting future behaviors is a major challenge since mammals' responses to temperature are nonlinear and data at extreme temperatures are scarce. However, for protected areas to be effective, we need to start protecting habitats proactively. In the future, animals may start selecting against regions that they currently select for, so we must account for future changes when designating areas for long-term conservation. In summary, temperature has nonlinear and complex effects on mammals' movement rates and habitat selection, with effects cascading to the community level. Mitigating the effects of climate change will require careful and proactive action that accounts for changes in species movement behavior as well as changes in landscape dynamics. More work is needed on quantifying the effects of climate change on underrepresented species, such as small mammals, and future work should also develop more species-specific models that explicitly account for interactions between species, such as predator-prey interactions. For those interested in learning more, I have included QR codes that link to the manuscript I'm writing with my co-authors, as well as the GitHub repo with all of my code. And with that, I thank you for listening, and I would also like to thank all those who funded and supported this research.